The Big Bang Theory states that matter, space, and time came into existence from absolute nothingness. If the cause of the Big Bang is immaterial, then it's spiritual. If it's timeless, it can see the future because it's outside of our concept of time. And if it's spaceless, then it's beyond the limits of space, meaning it's infinite. Don't lose the thread. Stay with me. There are 122 fine-tuned constants that make life on Earth possible. The odds of aligning those 122 characteristics by chance? 1 in 10 to the power of 138. And according to the Borel principle in mathematics, any probability less than 1 in 10 to the 50 is considered impossible. So the only logical explanation for a 1 in 10, 138 chance that life exists is that God exists. Mathematically, it's impossible for life to exist in our universe the way it does without a creator. And now that we know this, let's travel through the universe and witness the masterpiece that God designed. You'll be astonished by what the James Webb Space Telescope has captured. The universe speaks in the silent glow of distant stars, in the quiet choreography of galaxies drifting through the void. For centuries, we only saw fragments of this cosmic symphony, until we built instruments powerful enough to listen more deeply. Telescopes expanded our perception, and the melody of space grew richer. Today, we have the most powerful eye humanity has ever turned toward the cosmos, the James Webb Space Telescope. But JWST isn't just a telescope, it's a time machine. Engineered to witness the universe's first moments, to capture the birth of the earliest stars and galaxies. Why does this matter? Because seeing the beginning means understanding the origin of everything that came after, including us. JWST sees an infrared light, an invisible wavelength to our eyes, but perfect for catching ancient signals stretched over time by the expansion of the universe. Its golden honeycomb-shaped mirror collects fragile photons, messengers that have traveled for over 13 billion years. Orbiting nearly 1 million miles from Earth, shielded from heat and light, JWST stays cold enough to hear the faintest whispers from the dawn of time. Each image it sends back is a portal to a forgotten era. We pointed the telescope at empty patches of sky and let it observe for days, peeling back layers of cosmic history. JWST isn't just looking at stars. It's chasing the story of how stars, galaxies, and even life itself began. It is the most advanced tool humanity has ever built to answer our oldest questions. And now, on July 18th, 2025, it delivered something that could rewrite the entire history of our universe's origin. From its first images, JWST delivered wonders, nebulas where stars are born, the violent chaos of stellar nurseries, where dust and gravity sculpt the cosmos. It studied the atmospheres of exoplanets, detecting water vapor and carbon dioxide, bringing us closer to the answer. Are we alone? It gave us new views of Jupiter and Neptune, revealing hidden details unseen for decades. But that was just the prelude. Its primary mission was always clear: to find the first galaxies that ever existed, the earliest structure, the first light. JWST looked deeper than any telescope before it, capturing light that traveled for over 13 billion years. Every red smear in its images was a clue to how the universe began to take shape, and the telescope was performing perfectly, even better than expected. But no one was prepared for what it would find next. To witness the cosmic dawn, astronomers pointed JWST at the Hubble Ultra Deep Field, a region already known for revealing thousands of galaxies. But Hubble had its limits. JWST could see beyond, fainter, farther, older. The plan? Let JWST observe this patch of sky for over 100 hours. Collect light that had traveled across nearly the entire history of the universe. Decades of theoretical models predicted the kinds of galaxies we'd find. Small, chaotic, irregular, no spiral arms, no heavy elements, just hydrogen and helium, the basic ingredients forged in the Big Bang. The mission was to capture those primitive galaxies, to confirm our theories of how the universe evolved from simplicity to complexity. But the universe didn't follow the script. The data came in, a torrent of it. As the images took shape, astronomers expected soft glows, proto-galaxies beginning to form. Instead, they saw giants. 6 massive, mature galaxies glowing brightly just 300 million years after the Big Bang. These galaxies weren't small. They held tens of billions of stars. Some even showed signs of defined structure, possibly spiral arms. It was like finding fully grown adults in a newborn's photo album. Even more astonishing, their spectrums revealed something unexpected. These galaxies weren't made of just hydrogen and helium. They were filled with heavy elements, carbon, oxygen, and more. Metals that should have taken billions of years and multiple star generations to form were already there. Somehow, these galaxies had become chemically mature, fast. According to everything we thought we knew, this was impossible. Think of it this way. Scientists expected to find a seedling. They found a redwood forest. They expected the universe's first whispers. Instead, they heard a full orchestra. This wasn't just surprising, it directly contradicted the standard model of cosmology. For galaxies this massive to exist that early, something fundamental in our understanding must be wrong. Maybe galaxies can form much faster under certain conditions, reviving the old monolithic collapse theory. Or maybe dark matter, and even gravity itself, behave differently at cosmic scales. Astronomy has just received a cosmic plot twist, and now the rules must be rewritten. This discovery doesn't just add a new detail, it forces us to rethink the opening chapters of the universe's story. If large galaxies already existed 300 million years after the Big Bang, then the ingredients for planets, and possibly life, were available far earlier than we ever thought. Suddenly, the earliest possible timeline for life moves up by over 1 billion years. And that raises another question. How did supermassive black holes grow so fast? None of our current models explain this speed. None. Science moves forward by confronting the unexpected. Theorists are now rewriting models. More JWST observations are being scheduled. If these ancient galaxies are rare, they may be exceptions. But if they're common, then our entire understanding of cosmic evolution must change. That's how discovery works. Not by confirming what we already know, but by revealing what we never imagined. And this discovery changes everything. JWST will continue to scan the skies, hunting for more of these impossible galaxies. And in doing so, it will guide us through a universe stranger, older, and more complex than we ever dared to dream. Every question leads to another. Every answer unlocks a new mystery. Because the cosmos is still speaking. And now, we are finally learning how to listen. Watch more videos on our channel and cross the frontier of curiosity.